Geometry, Unit 7, which is Chapter 5 from the book, Section 6, Properties of Special Parallelograms. So let's look at our first special parallelogram. We're going to look at a rhombus. Now, a rhombus is a parallelogram. That means it has all of the properties of parallelogram. So that means opposite sides are congruent, opposite sides are parallel, consecutive angles are supplementary, opposite angles are congruent, and diagonals bisect each other. It has all of those properties. Every shape we're going to be looking at has all those properties. But a rhombus has a couple of other unique properties. All four sides are congruent. So all those sides are congruent. The diagonals are also perpendicular. So that all the diagonals intersect at a 90 degree. And the diagonal bisect the angles of the rhombus. So each angle here is bisected. Now, since opposite angles are congruent, and then they're bisected, you can see all the angles from A and all the angles from C are congruent, and then all the angles of B are congruent to the angles of D. So again, a rhombus has all the properties of a parallelogram, and then it's got a few additional properties. So let's look at and see if we can use this concept to solve a problem. Find the perimeter of a rhombus. We're given AE is 3, EB is 4. Now, using the property of a rhombus, we know that this is a 90-degree angle. So now we can use the Pythagorean theorem to solve for AB. 3 squared plus 4 squared equals x squared, so that's 9 plus 16, which is 25. Square root of 25 is 5. So the perimeter, since each side is 5, because all four sides of a rhombus are congruent, 5 plus 5 plus 5 plus 5, the perimeter is 20. Now let's look at a rectangle. A rectangle is a parallelogram. That means it has all the properties of a parallelogram. So again, opposite sides are congruent, opposite sides are parallel, diagonals bisect each other, consecutive angles are supplementary, and opposite angles are congruent. So, rectangle has a few unique properties of its own. All the angles are 90 degrees. So every angle is a right angle, and all the sides are perpendicular. But also, the diagonals are congruent. Now, if we combine that with the properties of a parallelogram, because it is a parallelogram, since the diagonals bisect each other and they're congruent, all these are congruent. So let's use this idea to see if we can solve for a problem here. So find the perimeter of this rectangle. We're given AC is 12. So this full length is 12. Well, we know this is a 90-degree angle, and we have a 30, 60, 90 triangle. Well, if we remember the properties of 30, 60, 90, the side that's across from the 30 degrees is half of the hypotenuse, so that's 6. And then the side that's across from the 60-degree angle is the square root of 3 times the short side, so that's 6 squared root 3. So then this side's 6 squared root 3, this side's 6. So the perimeter of this rectangle is 12 plus 12 root 3. Now, let's look at the properties of a square. Since a square is a parallelogram, it has all the properties of a parallelogram. It's also a rhombus, thus it has properties of a rhombus. It's also a rectangle, and thus it has all the properties of a rectangle. So all four sides are congruent. All your angles are 90 degrees. Diagonals intersect at 90 degrees, and diagonals are congruent. So that's all the properties of all those shapes. So let's do this problem. The perimeter of the square is 100. What's the length of the diagonal? So if the perimeter is 100, each side's got to be 25, because 100 divided by 4 is 25. Now let's find the length of the diagonals. Well, we can use Pythagorean theorem We also could use, if you remember, properties of 45, 45, 90 triangle. One way or the other, whether we do Pythagorean theorem or use those properties, we end up with the diagonal being 25 square root 2. So let's look at some of these problems in a graphical coordinate plane sort of thought process. So let's determine what shape is graphed below. Well, if we don't know the properties of a shape, we can never identify it. But knowing the properties, we can identify what the shape is. So let's start off with, let's look at the lengths of all these sides. The length of this side, down 4 over 1, so that's 4 squared plus 1 squared. That's x squared. So that's 16 plus 1 equals x squared. So x is the square root of 17. This ends up being the same because that's down 4 over 1. So those are congruent. This is up 1 over 7. So we do the same thing, 49 plus 1. So that's the square root of 50. Same thing, look. Over 7, up 1. So I know at a bare minimum it's a parallelogram because I proved opposite sides are congruent. And I know it's not a rectangle because I can use slope to show that these are not perpendicular. The slope of this line, as I said earlier, is down 4, forward 1. The slope of this line we did as up 1 over 7. Those are not perpendicular. Remember, perpendicular slope is the negative reciprocal. In other words, I flip the fraction over and change the sign. Well, if I flip this fraction over and I change the sign, it's negative 7 over 1, which is not the same. So they are not perpendicular. So it's not a rectangle, and it's not a rhombus, because all 4 sides aren't congruent. It's got to be a parallelogram. Let's see what this shape is. Well, let's see. Let's do sides down 4 over 3. So that's 4 squared plus 3 squared equals x squared. So that's 16 plus 9. That's 25. Square root of 25 we know is 5. Well, look, over 4 up 3. Oh, that's also 5. Over 4 up 3, it's also 5. Over 4 up 3, so it's also 5. So I've shown that it is a rhombus, but it could be more than that. It could be a square. Well, it's a square if these angles are 90 degrees, because that's combining the properties of a rectangle with properties of a rhombus. So how can I do that? Using slope of this line, up 3 over 4, slope of this line, down 4 over 3. They are negative reciprocals. It is a square. So I showed that all 4 sides are congruent, and then I also showed that they are perpendicular. And that is the end of this lesson.